Hey, good morning, listeners. Welcome back to yet another episode of 5G 60 Pulse. It is a calm and peaceful Sunday morning. I am your host, Moti Derani, and I would like to thank each one of you for giving the amazing response to this podcast series. And today, we are diving deep into one of the most powerful shifts happening in telecom today. How AI native design in 6G is redefining the future of radio access networks. To make this easier to follow, I have broken it down into six key segments so you can absorb it step by step. The segments are what really pushing the telecom world towards the AI powered RAN. How is AI currently being used in RAN? Why do we really need AI in modern network? What real value does AI actually deliver in the network? How is 6G implementing AI in a truly native way? And finally, what challenges do we need to anticipate and prepare for? Let's dive into the first segment. Let's see the first segment, which is what really pushing the telecom world towards the AI powered RAN. AI adoption in telecom is no longer a buzzword, it is a necessity. Today, demands on networks are growing like never before. We need more speed, we need to support more devices, and we need to enable more advanced use cases like autonomous vehicles and smart manufacturing, which demand ultra low latency. And here's the issue: traditional RAN were never designed for this level of complexity. They still rely on fixed rules and require manual configuration of thousands of parameters. Everything from power level to hand over the shore that need to be tuned by human engineers. This legacy approach is rigid and reactive, leading to slow response to network congestion, increased call drops in high traffic area, underutilized or overused spectrum, significant energy inefficiency, and rising operational costs. This means networks are reactive, not proactive. They can't adapt fast enough when traffic spikes or usage pattern shift. That's the core reason the industry is shifting towards AI powered self optimizing networks. With AI, we move from manual configuration to autonomous adoption, from reactive troubleshooting to proactive decision making. Now, let's understand the second segment, how AI is being used in REN today. You have probably heard of SON, self optimizing network. It was a great leap forward when it was introduced in 4G. In the current system, sound functionality of 4G and 5G is no longer sufficient, and that's why AI is the way forward in RAN. Currently, SON provides basic automation to optimize network parameters like handover, load balancing, and coverage. Things that would otherwise take hours or days to fine tune manually. But here's the truth: SON is showing its limits in today's telecom landscape. Because SON is based on predefined rules, it can only act within the boundaries you have programmed into it. It does not learn from real time data. It does not adapt to new traffic pattern or user behavior on its own. It's reactive, not predictive. So when the network suddenly faces congestion, interference, or unexpected surge, SON can't keep up fast enough. Now, how AI help it? Network can learn from live data, understanding user behavior, predicting congestion, and dynamically optimizing performance. Network can even adapt to business intent, whether the goal is ultra low latency for surgery or high throughput for applications like immersive XR, or want to prioritize latency for autonomous vehicle at rush hours. The network can reconfigure itself automatically. AI turns a static network into an intelligent real-time decision engine. With AI integrated into RAN, we get what we now call a high-performing programmable network. Let me give you an analogy. Zone is like a car with cruise control, automated but limited to predefined logic. AI powered RAN is truly a fully autonomous self-driving car that sees the road, adapt to traffic, and reroute instantly. Now let's understand the third segment. Why do we really need AI in modern network? Because today's telecom world is unlike anything before. Networks are getting more denser and more complex. They need to serve more traffic, more devices, and more types of application than ever before. Devices are becoming smarter than ever. User behavior is highly dynamic, very unpredictable, and we are expanding into terrestrial, aerial, and space-based connectivity. We need networks that think of themselves. With AI, network can plan, configure, optimize, and heal automatically. This is possible because network will continuously learn from data, adapt to user behavior, and predict and prevent issues from before users notice. Most importantly, it is unlocking something we call zero touch automation, freeing humans from endless tweaking. AI does not rely on static rules, rather, it learn from pattern, predict changes before they happen, adapt instantly to new scenarios, and optimize performance continuously. It evolves as network grows. Now let's talk on the impact in the fourth segment. What value does AI actually deliver, especially in the radio access network? AI in RAN is already delivering tangible benefit in three key areas: performance, energy efficiency, automation. Let me elaborate a bit. It reduces call drop, especially in dense cities or when users are moving fast. It boosts spectral efficiency, meaning we can get more out of the same frequency band. It optimizes energy use because AI knows when and where to power down underutilized sites intelligently without affecting performance. And it cuts operational costs by automating tuning, troubleshooting, and load balancing. Now, fast forward to the 6G area, 6G era, uh, where AI is not just an add-on; it is built into the DNA of the network. This is what we call AI native RAN. With it, we can see even higher spectral and energy efficiency, ultra low latency for mission critical applications like remote surgery or autonomous vehicle, massive scalability to support billions of IoT devices, built-in security with AI proactively detecting and stopping threats, and yes, significant cost saving with energy smart operation that align with sustainability goals. This is not far off vision, it is already unfolding, with leading operators and forward thinking nations investing billions to embed AI deep into the telecom RAN. We are not just building smarter network, we are entering an era where networks are smart by design. Now, in the fifth segment, let's see 6G planning to implement AI in a truly native way. As we move into the 6G era, we are shifting from rule-based automation to AI native autonomy, where network don't just follow instructions, they learn, decide, and evolve on their own. 6G won't just support AI, it will be built around AI. We are entering an era of AI native RAN, where the radio network itself is intelligent, adaptable, and self optimizing. Unlike 5G, where AI is layered over existing protocols, 6G protocols themselves will be co designed with AI models that is, embed AI across all layers of RAN stack and make them adaptive and optimized from the start. Now, it won't just automate, it will learn. It won't just respond, it will predict. And it won't just react to traffic, it will understand intent and allocate resources in real time. So, how exactly is 6G AI native intelligence deployed across the RAN? The answer lies in a hybrid architecture where AI is distributed both centrally in the cloud or core network and locally at the edge, right down to the basement unit at every cell site. Centralized AI deployment in the cloud or core network. This is where the heavy duty AI processing happen. Think of it as the brain doing long term training, analyzing huge volume of historical and real time data across the network. It runs large AI models to predict traffic trends, detect regional anomalies, or optimize network-wide energy use. For example, if an operator wants to analyze nationwide data to predict where a coverage boost is needed next month, that's a centralized AI job. It is a central AI where new AI models are trained, tested, and then pushed to the edge of local execution. Now take a look on the edge AI deployment at the RAN inside baseband. Here where things get exciting. In 6G, AI models are also embedded directly into the baseband processor at every cell site. Why? Because many RAN decisions like beamforming handover, interference cancellation, or scheduling need to happen in milliseconds. And waiting for the cloud to respond, too slow. So lightweight compressed AI models are deployed inside the basement, enabling real time decision making at the cell level, local learning based on immediate traffic and user behavior, and autonomous optimization without human input or cloud dependency. This edge level AI is the foundation of ultra low latency, zero touch automation, and energy aware RAN behavior. In return, we will get a programmable network that's self-healing, self-optimizing, and deeply aware of what each device and user needs in real time. Now, finally, in the sixth segment, let's take a look on the challenges with 6G AI native. AI in 6G RAN is not just supporting the network; it is making autonomous decisions about spectrum use, beamforming handover, interference mitigation, and even security. But what happens when that AI makes a wrong call or when it hallucinates? In generative AI, hallucination means the AI generates output that sound possible or doable, but are factually wrong. In the radio access network, hallucination could mean misinterpreting network signals, predicting demand that never comes, switching off a site when it's actually needed, or triggering a false handover or interference alert. So, how will these challenges be addressed? AI models in RAN must be interpretable and traceable, not black boxes. That is, implement human in the loop system for override and supervision. Operators need to understand why a decision was made, especially when things go wrong, and build a fail-safe fallback mechanism if AI misfire. The system revert to non-safe states. You might recall that famous line from the movie Spider-Man: "With great power comes great responsibility." Well, the same applies to AI in 6G RAN. It has incredible power, but we also carry the responsibility to build trust and ensure resilience and design for transparency at every layer of the network. Because intelligence alone is not enough. What matters is how responsibly we use it. So, with that being said, it brings us to the end of today's episode on how AI native design in 6G is powering the next evolution of radio access networks. We are not just building better network, we are building intelligent self-evolving system that can learn, adapt, and optimize on their own. This high performing programmable network are not the future, they are becoming the new standard. Thanks for tuning in. to this episode of 5G 6G Plus. If you found this valuable, drop a review and share it with your tech circle. And don't forget to hit the follow button on your favorite platform so you will always get updated with the new technologies and trends. Until next time, stay curious, stay connected, and keep pushing boundaries. And as the music fades in, take a moment to reflect on today's key takeaways from the limitation of traditional network to the promises of AI powered RAN, from understanding why AI is being essential in the modern telecom to uncovering the real value it delivers, and from the promises of 6G AI native design to the critical challenges we must address moving forward. This new shift is already in motion, and it is up to us to lead this shift with purpose and precision. Thank you, take care, God bless, and catch you in the next one. Bye.